Hello students, in this video I'm going to demonstrate how to find the slant asymptote and graph a rational function. In order to find first of all, I know it's going to have a slant asymptote because the top degree is 1 degree larger than the bottom degree. In order to find the slant asymptote, I'm going to use synthetic division. I'm going to take the coefficient of every term of each degree on the top, on the numerator, and divide it by 7, which is when I set the denominator equal to 0 and solve. So I'm going to have a 1, 1, negative 42, and out in front I'm going to have a 7. I bring down the first term. 7 times 1 is 7. I add my columns. 7 times 8 is 56, which is going to create a remainder, which I don't utilize when I'm looking for the slant asymptote. I'm going to take this information and put it back into a polynomial. I started with a second degree polynomial, and I've taken 1 away, so now I'm going to have 1x plus 8. So this becomes my slant asymptote, y equals x plus 8. I can graph this slant by acknowledging that the slope is 1 and the y-intercept is 0, 8. Okay, now that I've got my slant asymptote, I want to go on and I want to completely find the information I need in order to graph this function. The first thing I'm going to do is I'm going to factor the numerator and the denominator. So if I factor the top, it has a leading coefficient of 1, so my x's are separated. My last sign is a minus, so that tells me they're going to be different signs. My first sign is plus, so because this is minus and this is plus, my larger factor will be positive. Factors of 42 that subtract to get 1 are going to be 7 and 6. And I bring over my denominator. And I look to see if anything cancels. Notice that nothing cancels. Therefore, I can take my denominator and set that equal to 0 and look for a vertical asymptote. So x equals 7 is going to create a vertical asymptote. So I always graph as I go. I don't wait till the very end. I graph as I go. Now that I've found my vertical asymptote and my slant, I've already determined there's no horizontal asymptotes. I'm going to find my intercepts. To find my intercepts, the first thing I'm going to do is I'm going to plug in 0 for all my x's. So I'm going to end up with negative 42 over negative 7, which reduces down to a positive 6. So when f of 0, when x equals 0, my y value is going to be 6. So I'm going to go ahead and plot that. 0, 6. Now I'm going to find my x-intercepts. To find my x-intercepts, I'm going to set my numerator, the top, equal to 0. And since I already have it in factored form above here, I'm going to go ahead and write that down here. X, and I set each of these factors equal to 0 to solve for my x-intercepts. I'll get x equals negative 7 and x equals positive 6. And I want to go ahead and put those into my graph. Now notice I have these 3 points that are within this interval. So I can go ahead and graph this part of my graph. I know that by definition, the graph is getting closer and closer and closer to the asymptote. It's got to come up here to go through 0, 0, 6, and it's got to come back down to go through 6, 0, and then it's going to continue to go on closer and closer to the vertical asymptote. So that part's already been graphed for me just by the information I found. Now I have no idea what's going on over here. Is my asymptote going to be over this way, or is it going to be up here? Well, I know I have no other x-intercepts, so I already know it's going to be up here. But in order to better graph this, I'm going to have to plug in a point to determine exactly where it's at. So my vertical asymptote is at 7, so I'm going to plug in positive 8 into my function. So I'm going to have 8 squared plus 8 minus 42 over 8 minus 7. 64 plus 8 minus 42 over 1. So 8 plus 64, 72 minus 42 over 1. So I have 30. So 30, each of these are by 4. So 4, 8, 12, 16, 20, 24, 28, 30. So about there. And so now it's going to get closer and closer to that direction, and it's going to have to get closer and closer that direction. And I've got my graph. I hope this was helpful. Have a great day.